Oh, sorry. Oh, wait.
Alright.
Oh, okay. Why don't you
Okay. For number 1, this cannot be done on Desmos, so you have to know how to do this. Waiting for everyone to type in. Okay. So if we're reading this and we're translating, the quotient of everything after that is going to be dividing 3 times the number squared, and this tells us what we're dividing, 6 less than a number. If it said a different number, you would use 2 different variables. So we can use the same one here. So 3 times a number squared, the quotient of this, so we're dividing 6 less than a number.
Oh, yeah.
Oh.
If you want. It doesn't need it. Okay, so the variable doesn't matter, but it should look like this format. Questions on that?
18.
Wait, is this a less than a number?
So less than means subtracting, and then the number is really the variable.
So why is it X?
Less than.
Yeah, but why don't you put just the number? Why do you put an X?
So anytime it says number, it's talking about a variable.
Why?
Because it looks X.
Say it's crazy.
Alright. Number 2 can be done in Desmos. Ladies and gentlemen. You could do this a couple different ways. Either put it in as is with the n, or use parentheses. I'll put it in with n. Absolute value is down here, or you can type in the letters ABS and use parentheses. It'll work the same. Add in your slider, change that number to -15. And our answer is -2.
This is supposed to be -9.
I was right.
It was -9 if you were doing it by hand. It was -9, then it would have changed to a positive, and then when you multiply the negative and the positive, you would have
I thought you had to divide the -2.
You're not dividing.
Why? Do you have to do the opposite?
Because you're not solving, you're simplifying. You're not moving things to the other side. You're just doing whatever you see, which is multiplying. If there were equals and you moved it over, yes, you would divide, but not in this case.
But how do you know which case?
If you don't see an equals, you're not solving.
Wait, I'm really sorry. Multiplying. I don't have to do multiplying. Okay, how should be -21? Oh wait, -2. Oh,
Negative. What? Huh? I did not do that.
yeah, that's not what I was thinking at all.
Actually, -9.
-9 is -15 plus 6.
Correct. Alright, number 4. You don't need that work if you did it in Desmos. This one can be checked in Desmos. But we need to find the y-intercept, which is 3. The slope of this, if you find points along the line that cross the grid lines or would cross the grid lines exactly, it looks like we're going up 2 to the right 3, down 2 to the left 3 along the line. And then this is a dashed line shaded above, so that's going to be y is greater than 2/3 x plus 3.
What?
Questions on that? If you wanted to double check yourself in Desmos, you could put this into Desmos, and you'll see that the slope and y-intercept are the same. The line would be dashed, and it would be shaded above. Okay. We're going to go over the SOL A4A and B questions.
Who's gonna do this and take pictures of it for me? Because I don't know. Oh wait, but I can't put them in because she sees how many. Okay. I can read.
So, even if you don't have yours, make sure you're writing it down on a piece of paper or something so you can put them in at a later time. Write down just the answers, and then I'll show you how to do these on the.
I'm sorry. You did all of that work for number 1 just to get x equals 0.
I didn't make up the problem. I just did. I just solved it.
So sad.
So, number 1, x equals 0. Number 2 and 3, even though you don't know how to solve this, you should know that solutions and roots are the same thing as x-intercepts. So if you were to put that into Desmos and graph it, you could find the x-intercepts. So you could write it like this, or as ordered pairs, or x curly brackets, -4/3 and 2. And number 3, x equals -6 and 2/5. Once you finish that, go on to the next page. And then I just put these in Desmos, and I'll show you what that looks like just in case you've forgotten. Number 4, no solution. Number 5, 1 solution, x equals 0. 6 and 7 were both infinitely many solutions. 8 was C, the only solution is 0, or x equals 0. Number 9 was D, x equals 7. 10, x equals -12.5. 11 and 12 were the same as 2 and 3 from the previous page. So x equals -4/3 and 2, and x equals -6 and 2/5. So finish that and go on to the next. Is that B or 6? -6. I want to get that. 13 was D. 14 was C. Again, if we're identifying solutions, you're looking for x-intercepts. 15, the solutions were the x-intercepts, so draw a point there. Focus. Okay. And then 16, you don't have to write what's in the parentheses, but everything on the lines you do. So you're looking for what happened between each set of steps. This one and the next one are the only two from this section that cannot be done on Desmos, because you have to know your properties. So from step 1 to step 2, subtraction property of equality, or POE. Step 2 to step 3, additive inverse. Step 3 to step 4, substitution. Step 4 to step 5, additive identity. 5 to 6, division property of equality. And 6 to 7, multiplicative inverse.
Okay, guys, let's It's not quick. We don't feel so tension. No.
There's nothing good. Oh, I'm sorry. What's wrong with that?
I don't want to go to practice. I want to be careful.
When you finish with this, go on to the next page.
We just put a bag from the shed.
The shit.
This is really hard.
17 was C. Alright, really quickly, I'm going to show some of these in Desmos. And then so, almost all of these could have been done in Desmos. If you type it in, you get your equation, you get your answer. Look for a line. Look at the x value, x equals 0. For the ones you don't know how to solve, put that in. Look at your x-intercepts, and you can find those solutions. If you get something where nothing appears, put them in separately. And you'll see that they're parallel lines, so no solution. Same thing here. If you get something, I have something else put up here. If you don't see anything, put them in separately. You'll see that they overlap, so infinitely many. And then other solutions. When we get back, we're going to finish our notes from last class. So if we were using algebra tiles, now this one is not a binomial and binomial, it's a monomial and a binomial, but it'll get us practice for the upcoming class. So if we were to multiply -2 to everything here, I have -2 on one side and the x minus 1 on the other. We're multiplying each thing to each thing. So -1 times x would give us -x. And when you do this with algebra tiles, you want your end goal is to kind of make this into a square or a rectangle. We know this one would also be -x. And then -1 times -1, +1. Same thing here, -1 times x, -1x. We're going to do times 3. Just going to put it in 3. And then that same thing would happen for this next set of x's. I'm just putting them in there. I don't even really have to do this because it's going to move them around for me. Not one too many. Alright, and then -1 times 1. -1. So then if I calculated the total, I'd have -12x minus 4, which is the same thing as us just distributing. But now we have two different binomials, so we have each binomial on each side, and we do the same thing. Multiply each piece to each piece. So x times x would give us what? Not 2x. X squared. We're multiplying the like bases, so we're adding the exponents. Let's take this off. That was already off. It doesn't really matter if you go across or down first. I'm just going to keep going down. And then 1 times x. Just x. Sorry, you can go. Unless you want to wait. Yeah. Right, and then we know this would also be x. If I could do this over there, I would, but it doesn't like this app. This is in Canvas. It's called Electronic Algebra Tiles. If you would like to go into this and go into expanding brackets. And then, not negative. Then we have 3 positive ones. So you may have seen that already, but how would I read that total amount?
2x
plus 7x
plus
7x plus 3. Yeah. So we'll do one more of these, and then I'll show you how to do it algebraically. Okay, so we have x times x, which would give us
x squared.
X squared. And then x times 1 gives x. And that would be the same thing here. I'm going to just leave those. And then 1 times 1 would just give us 1. How would we read that?
4x squared plus
4x squared plus 4x plus 1. In the 2 examples we just did, we didn't have any with 0 pairs where we had negatives and positives. We would bring those together, cancel them out, see what's left. But if you would like to multiply your binomials together with algebra tiles, you're welcome to do that. Yes. While you're practicing, again, if you want algebra tiles, I can go get those for you. Now I'm gonna show you how to do it algebraically. And I'm gonna show you a couple different ways, so you choose whichever method you like. One is just to think about this like you're multiplying everything to everything. So we have to kind of double distribute. Multiply everything, this first term to everything here. And this second term also to everything here, so I'm going to rewrite it, rearrange it, so that we have x times x plus 7, and then plus 5 times x plus 7. And then we're just distributing. So x times x would give us
x squared.
X squared. X times 7.
7.
7x. 5 times x.
5x.
And 5 times 7.
35.
Then we have like terms that we can combine. So if we combine them, what would our new polynomial be?
X squared plus 12x plus 35.
X squared plus 12x plus 35.
Apparently they should hurry up and stop causing a problem.
Yeah. Did you have questions about that?
Just gonna be in the quiz.
Yes. Alright. Another way we could distribute, so if you like the double distribute or you like the algebra tiles, use those. Don't worry about anything else I'm going to say. If you like what I'm about to say next, do that instead. So there's a specific order when we distribute, and we use the mnemonic FOIL. And this stands for first. So that's the first term in both set of parentheses. Outer. So that's the outside terms. Inner. The inside terms. And then last. The last terms in both sets of parentheses. Now, this time we're going to do it using this mnemonic, writing out each thing, but as you get used to this, you won't need to do it the way we're about to do it. So if we multiply it in this format, our first would be x times x, which would give us x squared, let's see. Our outer terms, x times negative 6, negative 6x. Our inner terms, 9 times x, 9x. And then our last terms, 9 times negative 6.
Negative 54.
Negative 54. Just like what we did before, we're going to combine our like terms and rewrite it into standard form. If we did that, what would we have? What would our final answer be?
X squared plus 3x minus 54.
X squared plus 3x minus 54. Questions on that? Max? Which part? Multiply your first terms, your outer terms, your inner terms, and your last terms. And then combine like terms. Now, we're going to use the same mnemonic, but not write all that work. So if I'm doing this first, 5x times x, and if you still want to do this, you can. 5x times x would be
5x squared.
5x squared. And then outer, 5x times negative 4. Negative 20x. Inner, 2 times x. Plus 2x. And last, 2 times negative 4. Negative 8. And then combine like terms. What would that be?
5x squared minus 18x minus 8.
Whoa. 5x squared minus 18x minus 8. So if you like one of the ways we've done this so far, keep doing that. I'm going to show you one more way. Max, you had a question? Depending on what science class you're in, you may have seen this before. Who here has seen or remember seeing something about a Punnett square? Right, so we're going to do something like that. So however many terms you have is going to determine the box. So we have 2 terms and 2 terms, so you need a 2 by 2 square. Make it big enough that you can write in, but small enough that you can write on top and on the side of also. Does not matter which one you put on which side. So let's say I put 3x minus 10 on the top and 2x plus 1 on the sides. Again, does not matter which side. And then kind of like the algebra tiles, we're going to multiply each set of things together. So 2x times 3x, 6x squared, 2x times negative 10,
Negative 20x.
negative 20x, 1 times 3x, 3x, and then 1 times negative 10. Negative 10. And then in the box itself, you can combine like terms. So we know 3x and negative 20x would combine, and then rewrite this. what would our final answer be?
6x squared minus 17x minus
6 squared minus 17x minus 10. You could also rewrite all four terms and then combine them. That order does not matter. So of all the different methods, hopefully you have one that you like and continue to do that. We're going to do one of the binomials to polynomials, which you have at the bottom. You could do algebra with this. You could do the double distributive with this, and the box method with this. Not really the FOIL method because of the in-between number. So of those three methods, which one do we want to see for this? Box method. You can do that and see if this is it.
Yeah.
So if we're doing the box method, we have 2 and 3, so you need a 2 by 3 rectangle. Doesn't matter if it's long. It could be 3 by 2 or 2 by 3. It doesn't matter. Now I'm going to make sure you're writing this down. So I have x plus 2 and x squared plus 3x plus 4. And then we just multiply each piece. So x times x squared would be x to the power of 3. Remember, there's an invisible exponent of 1. X times 3x. 3x squared. X times 4. 4x. 2 times x squared. 2x squared. 2 times 3x. 6x. And 2 times 4. Right, and then we can combine like terms. Either you can write them all down and then combine them, or combine them in here. So we have 2 things that are x squared and 2 things that are just x's. So if we were to write out our final answer, we're going to start with x to the third. And then what would the rest be? Not 6, but 5 x squared plus 10x, and then plus 8. And that would be your final answer. Do we have any questions about that?
So I think the first box is the one that goes first.
Usually, unless this was not in standard form. If you had like 4 here and x squared here, it wouldn't go first. Highest exponent goes first. Max, fair. Other questions about this? Okay. I'm going to give you guys time to practice, and you have a bunch of different things you could be practicing. I'm going to give you guys your review, so you could start practicing that, look over that. The front page is going to look similar to another piece of notes you already have, but the rest is going to look different. You could keep practicing in these notes. Remember, there are a bunch of different practices here. I think the back, the last few pages are binomials to binomials and binomials to polynomials. You have your 2 delta maths that are due this Friday, scientific notation and polynomial operations. The 2 that were due last Friday. Your, I did not say this. The next SOL things that are due are all of SOL A4C through SOL 5B. So start at 4C and work your way up to 5B. So you can be working on any of those things. Alright, so use this under practice. You guys can work together, move around, use the iPads to double check yourself in Desmos. Let me know if you need my help or have any questions.
There's a restroom.
Yes.